Okay, so let's do some lectures on 11.4 and break 11.4 into two major parts. I'll probably break down 11.4a into three pieces just so it's a little easier for you to see. Okay, so what we're going to do in 11.4, let's suppose we got two sequences, AN and BN, and they're both bigger than 0. So I got two positive sequences, and let's suppose that AN is less than or equal to BN for all n's. Now let's look at this series made from these sequences. What can you say about the series n equals 1 to infinity of AN versus the series n equals 1 to infinity of BN? Well, I'm adding up a bunch of smaller numbers and I'm adding a bunch of bigger numbers. This guy's going to always have to be greater than or equal to that guy. Could be equal because the guys are equal. Could be equal. Okay, so now each of these sequences, each of their partial sums, each of these guys' SNs are increasing because you're adding a positive number to them each time. So they're increasing. So this guy's going to be monotonically increasing as a sequence of partial sums, and this guy's going to be monotonically increasing with the sequence of positive terms. So what can we say if we know that the summation n equals 1 to infinity of Bn converges? What can you automatically say? If this guy converges, it's going to go to a number. That puts a cap on this guy. So now we have the partial sums of this guy are a monotonically increasing sequence, and they're capped above. So that's going to tell me that the limit of the partial sums of the summation AN has to converge. So if I got this, if I got two positive sequences, I turn them into series, and this one's always smaller than that one. If this guy converges, this guy has to converge. Okay. What if I got the same scenario, two positive sequences where the ANs are way smaller than the BNs for all n? What can I say about the series of Bn if I know that AN goes to infinity? So if I know that the summation n equals 1 to infinity of AN equals infinity, what can I automatically say about that guy? Well, these are all positive. It's increasing and it's bigger than this guy. So therefore, the summation n equals 1 to infinity of Bn diverges to infinity. So to put together, this is called the comparison test. And what you have, if this guy, so you got two sequences, two series. If this guy converges, then this guy converges. If this guy diverges, then this guy diverges. Now, if this guy diverges, doesn't say anything about this guy. But if this guy diverges, that one has to diverge. If this guy converges, this guy has to converge. If this guy converges, it doesn't say anything about this one. Okay? So, again, if you want to show that this one converges, get somebody bigger than it and show that it converges. If you want to show that this guy blows up, get somebody smaller than it and force this one to blow up. Okay, I'm stop right there and let that sink in, and we're going to do some examples.